Hello boys and girls, welcome. In today's video we're going to continue with your lessons about hydrocarbon nomenclature. Today we're going to talk specifically about naming branch chain alkanes and their nomenclature. Before we go into the actual content, we need to talk about what is a branch chain alkane. In here we have a straight chain alkane. If you guys already forgot the rules for naming straight chain alkanes, I recommend that you guys go back to our last video and review them. This alkane over here has 4 carbons in its main chain. What happens is that sometimes other atoms take the place of these hydrogens on the main chain. And this can be a carbon, this can be a bromine, and chlorine and iodine. It can be any atom, almost any atom specifically. But for the sake of this lesson, we're going to use a carbon then. So, because this carbon took the place of this hydrogen, it is now known as a substituent because it is substituting these hydrogen over here. Now, what's going to happen then for this carbon? Well, it will eventually also form extra bonds. In this case with hydrogens, but also it can be with more carbons, bromines, iodines, chlorines, you name it. For the sake of this example, we're going to use hydrogens as well. So now this main chain has a branch that is coming out of it. And that specific branch, which means the carbon and its hydrogens, or any number of carbons that stem away from this main chain, are now called alkyl groups. Because this main chain has now a branch, because it now has an alkyl group, it is now known as a branch chain alkane. Alright, so now that we know what a branch chain alkane is, we gotta talk about a couple of specific things. First of all, a straight chain alkane can have as many branches coming out of it as possible. As a matter of fact, each carbon can have up to 2 branches coming out of it. And this one specifically can have up to 3, for example. Because remember that these atoms, these carbons, replace the hydrogens. So, this carbon over here has the ability to replace 3 of its hydrogens. This one only 2. This one 2 also. This one only has space for 1 more substituent in its chain. So again, the main chain can hold a very large amount of alkyl groups. So this specific alkyl group has the name of 4-ethyl 2,3-dimethylheptane. As you guys can see, the nomenclature for branch chain alkanes is extremely different from the one as straight chain alkanes. We will go over the steps for naming this branch chain alkane little by little. But I need you guys to focus and to pay close attention because it can get confusing at times. Let's go on then. So, we're going to use this same branch chain alkane and go step by step. First of all then, step number 1. Find the longest carbon chain in the structure. This will be the main chain or parent chain. To do that, we need to actually start counting the number of carbons without going back. So, if I start over here, for example, I go 1, 2, 3, 4, 5, 6, 7. Okay. Now, 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, 6. Oh, okay. 1, 2, 3, 4, 5, 6, 7. So in here, we have 2 options. We can pick this chain over here as the parent chain, as the main chain, or we can pick this one also as the main chain because both of them have a total of 7 carbons. Alright, I'm going to pick this one just for the sake of simplicity. So I went on ahead and I highlighted the parent chain. This makes it so much easier to identify what we're going to be working with, to basically organize your work. So okay, step number 2. number the main chain, making sure to pick the sequence that will assign the lowest possible number to the alkyl groups. These three alkyl groups, right? So what does this mean? Okay, we can start counting the number of carbons from this side of the chain or from this side of the chain. So if I start from this side, we already know that it's going to have 7, but this is going to be carbon number 1, carbon number 2, carbon number 3, 4, 5, 6, and 7. Now, what happens if I actually start counting from this side over here? This is going to be carbon number 1, carbon number 2, 3, 4, 5, 6, 7. So what does it mean to assign the lowest possible number to alkyl groups? If we start counting from this side, you're going to see that this alkyl group ends up in number 4. This one ends up in number 5. And this one ends in number 6. But if I start counting from this side, this one ends up in 2 instead of 6. This one in 3 instead of 5. And this one ends up in the same number. So, because this sequence over here assigns the lowest possible number to the alkyl groups, then we're going to pick this one. Okay, now for step number 3, I need you guys to focus. So I went on ahead and color-coded these alkyl groups over here. As you guys can see, because these alkyl groups are the same, I chose the same color for them. You'll see later on why that's important. So in step number 3, use the prefixes as in the main chain, which are meth, eth, prop, and so on, and add -il as a suffix to the name to name the alkyl groups. Why -il? Because these ones are alkyl groups. So what does this part mean? Well, this alkyl group over here has 1 carbon. It means that it will use the prefix meth, and by adding -il, it becomes a methyl. This one over here is the same, so it's also a methyl. This alkyl has 2 carbons inside of it, which means that we're going to use an eth. Plus adding -il, it means that it's going to be an ethyl. Alright? Use the numbers in the main chain to locate them. If there are more than 1 identical alkyl groups, you must include a second prefix to identify that. This second prefix includes di, tri, tetra, pentahexa, and so on. So as you guys can see, if we have more than 1 alkyl group that are identical, we need to use our common prefixes to actually identify them. So in this case, if we need a second prefix, we are not going to use we're not going to use meth, eth, and prop, and bute. We will be using di, tri, and tetra. Mono is not needed. So we have in here then 2 methyls. Because they are 2 methyls, 1 and 2 and 1 and 3, we're going to group them together. How? By saying 2, 3 hyphen dimethyl. Now we have an ethyl on 4. So 4 hyphen ethyl. In here, we must take a couple of notes. First of all, numbers are separated by commas. So as you guys can see, we have a methyl in 2 and a methyl in 3. So we got to separate that as 2, 3. All right. Where am I? Oh yeah. And numbers are separated from letters by hyphens. So it means that in here we have a number and we have a letter. We need to separate them by using a hyphen. Same thing in here. We have a number and a letter. So we separate them by using hyphens. Letters are not separated from other letters, and no spaces are needed. Okay? So that is step number 3. Step number 4. Arrange the alkyl groups in alphabetical order, ignoring the prefixes di, tri, tetra, and so on. Finally, add the name of the main chain. Let's go with this part first. So we have this again, 2,3-dimethyl, 4-ethyl. Arrange the alkyl groups in alphabetical order, ignoring the second prefix. That means that we're going to ignore this di, and we're going to have left over a M. Which one comes first, an E or an M? Yes, of course, the E, right? So we write for ethyl, for hyphen ethyl, because we are now going to put this in this part, we need to separate the letter from the number with a hyphen. So, for hyphen ethyl, okay, hyphen 2,3-dimethyl. For ethyl 2,3-dimethyl. Finally, add the name of the main chain. What was the main chain? It has 7 carbons in total, which make it a heptane. The final name of this branch chain alkane is 4-ethyl 2,3-dimethylheptane. You're probably thinking, whoa, this is super complicated. At the beginning, I'll be honest, it is. It tends to get very confusing in the beginning, but after a while, it becomes pretty mechanic, okay? The whole naming of branch chain alkanes becomes easier as you practice it. So you need to, first of all, memorize the rules. You need to know them by heart. And as we continue to practice them, you'll see how much easier it gets. On the next video, I'm going to show you guys a couple of more examples to help you guys with your nomenclature and your mechanical practice of this lesson. I'll see you then, boys and girls.